Good afternoon, everyone. This is going to be a review for Test 4. So let's get going. First part of the exam is going to contain a few problems just to get you in the mood of thinking about hypothesis testing. So for part 1, we've got for the following statements, write the null and alternative hypotheses. And then part 2, identify the test as left-tailed, right-tailed, or two-tailed. So part A says a Lysol can says that the spray kills 99.9% of germs, and we think not. Of course, we're the researcher. So part 1, let's structure the null and alternative hypotheses. Of course, this being a percentage here kind of tells us that the parameter that we're going to be testing is going to be P, the population proportion. So the researcher thinks that it's not the case that Lysol kills 99.9% of germs, and the null hypothesis is going to be 99.9%. The no change, no difference, no effect hypothesis. So this is a two-tail test. And then we'll move on to question 2. So the average number of patients treated for lupus at Hospital A is said to be 50 in any given year. We think it is more. So the researcher's hypothesis, again talking about the average, that points us to the parameter mu, and remember mu is the population average. And so we think it's more, mu is greater than 50, and mu is equal to 50. So this is a right tail test. Part C, a business says that their product A sells an average of 6 million units per month. We think it is less. So average, again, average points to the parameter mean, population mean mu. We think it is less. Less than is less than 6 and equal to 6. And this would be a left tail test. Okay, so let's try question 2. It says when people smoke, the nicotine they absorb is converted to cotinine, which can be measured. A report said that the mean cotinine level of all smokers is 200 nanograms per milliliter. We claim it is different from 200. A sample of 40 smokers has a mean cotinine of 172.5, and the sample standard deviation is 119.5. Test using a 0.05 level of significance, and we'll use the p-value approach for this particular question. Okay, so step 1 is to structure the null and the researcher's hypothesis in a way that goes along with the problem. So the first question really we want to find out is what parameter are we testing? Are we testing the population proportion P, or are we testing the population mean mu? And given the fact that we have all this information in the problem about the mean and standard deviation, we should know at this point that the parameter that we're testing is the mean. Okay, now what is the researcher trying to show? Well, we claim it is different from 200. And this word different here points us to a two-tailed test. So the researcher comes along and he says he thinks the mean cotinine level for all smokers is not equal to 200, and the no change, no difference, no effect hypothesis is that it is equal to 200. Okay, so that's step one. Step two is just state the level of significance, 0.05, and then step three is to compute the test statistic, x bar minus mu 0 s over the square root of n. So we have to find x bar, mu 0, s, and n. And so remember, x bar is the sample mean, so let's go back into the question where it talks about a sample. So here we go. We'll do this in red. A sample of 40 smokers, so 40 is our sample size, has a mean cotinine level of 172.5 and a sample standard deviation for 119.5. So let's jot these values down. 172.5, and the standard that we're comparing our sample evidence to is the 200. And then standard deviation is 119.5, and our sample size is 40. So let's plug this in. (172.5) minus 200 over 119 over the square root of 40. And remember, we're going to round t-scores and z-scores to 2 decimal places, so this comes to minus 1.46. Now, at this point, we have to choose either a p-value or a classical approach, and I believe this question wants us to go with the p-value method. So let's go ahead and write down the picture for the p-value method. And so we have this bell curve, and we have absolute value of t0 and minus absolute value of t0. And so t0 is 1.46, so we have 1.46 and minus 1.46. And this area here plus this area is the p-value. Alright, so let's get the formula down. The p-value is equal to twice the probability that t is greater than absolute value of t0. So 2 times the probability that t is greater than absolute value of t0. T0 we got to be minus 1.46. So we get 2 times the probability is greater. Absolute value of minus 1.46 is 1.46. Now we're going to use the TCDF function to get the p-value, TCDF, and this comes with a lower bound and upper bound and degrees of freedom. So this will be 2 lower bound. So the p-value is from 1.46 on out to positive infinity. So from this point all the way out. So the lower bound is going to be right here. That's the lower bound. And the upper bound is essentially infinity, positive infinity. But we can't enter positive infinity, so we have to use a really large number. So the lower bound is 1.46. And the upper bound is 1 times 10 to the 99. And degrees of freedom, remember, is sample size less 1. So the sample size in this case is 40. So that gives us 39 degrees of freedom. So let's look on to the calculator and see what we get for this particular p-value here. So we're going to hit second distribution, go down to TCDF, lower bound 1.46, comma upper bound 1 times 10 to the 99, comma degrees of freedom 39, close parentheses, enter. 0761, so our p-value is 2 times 0761, and then of course we multiply that by 2 and we get 1522. So step 5 says if p-value is less than alpha, reject the null. So the p-value is 0.1522 and alpha is 0.05. So if the p-value, this number here, is less than alpha, we reject. Well, that's not the case, so we fail to reject HO. And so we fail to reject HO, so the conclusion is we fail to reject HO, which is up here. The conclusion is that there's not sufficient evidence to conclude that the mean cotinine level for all smokers is not equal to 200. Okay, question 3.